Hello dear students, welcome to a new session. In this session, we'll be starting a new chapter, Unit 4, Chemical Kinetics. Now, what is chemical kinetics? It is basically a branch of physical chemistry which deals with the rate of a reaction. Rate of reaction means speed of a reaction, factors affecting the speed of reaction, and also its mechanism. Now, physical chemistry belongs to that chemistry where theories of physics are applied. In your class 12, from chapter 1 to chapter 5 belongs to physical chemistry. From chapter 6 to chapter 9 belongs to inorganic chemistry, and the leftover chapters are organic chemistry. Inorganic chemistry means a branch of chemistry which deals with every compound except carbon and its compound, and organic chemistry means it will deal only with carbon and carbon compound. Now here in this chapter we'll be studying about the speed or rate of a reaction. Now what is a rate of a reaction? Rate of a reaction basically means change in concentration of reactant or product with respect to time. We'll be studying about the change in the concentration of reactant and also the change in the concentration of the product with respect to time. Now, in order to study the rate of a reaction, we need a reaction. So here, the rate of a reaction cannot be determined for a very fast reaction. Suppose a reaction occurs within a fraction of a second. Its rate cannot be determined. And even if it is determined, it is of no use because it is occurring within a fraction of a second. And even the rate of a reaction cannot be determined for a very slow reaction. Suppose rusting of iron. Rusting of iron takes place very slowly. So such reaction which occur very slowly, the rate of reaction cannot be determined. The rate of reaction can be determined only for moderate reaction. That means those reactions which do not occur very slowly nor very fast. That means it is in between, moderate. Now here, in order for a reaction to occur, we need reactant and we need product. The reactant will combine together to give a product. Now what is happening in this reaction or any reaction? The reactant combine together to give a product. But what is happening in the reactant? Bond breakage takes place. Here nitrogen has 3 bonds and hydrogen has 1 bond. Now in the reactant, only if the bond break, new bonds will be formed. So bond breakage will take place in the reactant, and in the product, new bonds will be formed. Since bonds are breaking in the reactant side, there will be decrease in concentration. And since new bonds are formed in the product side, there will be increase in the concentration. So the rate will be given as, for the reactant side, it will be decrease in the concentration of the reactant with respect to the time taken. And for the product, it will be increase in the concentration of the product with respect to the time taken. Now let us see the mathematical part. Rate of reaction is basically expressed in 2 ways, average rate and instantaneous rate. The definitions are already given in your notes. Those are important, so kindly see it. The average rate. It is basically defined as change in concentration of the reactant or product with respect to time. And also, the stoichiometric coefficient will be divided. The small letter A, B, C, D, this represent the stoichiometric coefficient. The second one, instantaneous rate. This means the rate of the reaction is determined for very small change in time. Rate of the reaction takes place at a very short period of time. That is why it is known as instantaneous. Definition, please see the notes. In this case, del becomes equal to D. That means in this case, instead of writing del, we write D. In case of average rate, del X is the change in concentration of reactant or product over time interval del T. the time that we are taking is del T. Del X is just the change in the concentration of reactant or product with respect to time. And in the case of instantaneous rate, dx is infinitesimally small change in concentration in infinitesimally small time interval. Infinitesimally means very, very small. So instead of this, you can also write very, very small. Change in concentration. I have already told that it is for very short period of time. The change will take place at a very short period of time. We use the instantaneous rate given by dx by dt. Now let us see an example of a general reaction. The small letter A, B, C, D you see here, it is the stoichiometric coefficient. Firstly, we will be doing for the average rate. And average rate we have already discussed, it is given by del X by del T. Now we have already discussed previously that in the reactant there is decrease in the concentration, so it will have a negative sign. And in the product there is increase in the concentration, so it will have a positive sign when we are writing the average rate. Now let us write the average rate. It will start from the reactant. How do we write the average rate? It will be firstly divided by its stoichiometric coefficient followed by change in the concentration of the reactant with respect to the time. So what is the stoichiometric coefficient of A? It is A, small letter A. So it will have a minus 1 divided by A because we have to divide it with the stoichiometric coefficient. Now we have written for this. We will write for B as well. Don't forget to put is equal to sign everywhere. Is equal to minus again because again we are writing for the reactant B. So 1 by the stoichiometric coefficient, then the concentration of the reactant B with respect to its time. Now we have already written for the reactant part. We will now write for the product. It will follow with an is equal to sign. Now 1 divided by the stoichiometric coefficient, here it will have a plus sign because the concentration increases in product. So it will have a positive sign. 1 divided by stoichiometric coefficient followed by the concentration of the product C with respect to its time. Similarly for the product D, positive sign, 1 divided by stoichiometric coefficient, concentration of the product D divided by its time. This is how we are going to write the average rate of any reaction. Now we will write down what does all this concentration term means. We will not be writing the stoichiometric coefficient, we will directly denote the concentration term. Now as we have discussed that in the reactant the concentration is decreasing because bond breakage is taking place. Bond breakage is taking place means there is disappearance going on. In the product side the concentration increases because bond formation is taking place. So there is formation or appearance going on. So when we will write in this way that minus del concentration of the reactant A with respect to its time, it means that it is a rate of disappearance of A minus concentration of the reactant B with its time, it means it is a rate of disappearance of B. When we talk about the product, bond formation is taking place. So the concentration of the product C with respect to its time, it is the rate of formation of C, and the concentration of D with respect to its time is the rate of formation of D. Here disappearance or consumption is taking place, and here formation or appearance is taking place. When we are writing the instantaneous rate, we will be writing same as the average rate, but in this case instead of del we'll be using D. So for the reactant we know we'll have a minus sign divided by a stoichiometric coefficient D, concentration of the reactant A by time dt. Just the difference is in d. In the average rate we were using del. Here we'll use d. And everything will follow in the same way. Minus 1 by stoichiometric coefficient of the reactant B, concentration of the reactant B divided by its time. Now we will go for the product. Product will have a positive sign. 1 divided by the stoichiometric coefficient, concentration of the product C with respect to its time is equal to plus 1 by stoichiometric coefficient, concentration of D with respect to its time. Let us try to understand in a better way with the help of an example. Here we have one reaction. So we have to write the average rate and instantaneous rate. 4 moles of ammonia react with 5 moles of oxygen, giving 4 moles of nitric oxide and 6 moles of water. We have this stoichiometric coefficient. Now I'm sure you'll be clear what is stoichiometric coefficient. It is the number associated with the compound. So when we are writing the average rate for the reactant, it will be associated with a minus sign divided by stoichiometric coefficient followed by the concentration of the first reactant with respect to its time. Then it will be followed with the stoichiometric coefficient of the second reactant. Remember that the stoichiometric coefficient will be divided. That is why we are writing 1 by stoichiometric coefficient. Then concentration of the second reactant with respect to its time. Now the reactant is over. If there were more reactant, we will follow in the same way, putting a minus sign, but we have only 2 reactant. Now we will go for the product. That means it will have a plus sign divided by stoichiometric coefficient. Concentration of the first product with respect to its time is equal to plus stoichiometric coefficient, concentration of the second product with respect to its time. Instantaneous rate will also be written in the same way. Just in case of instantaneous rate, instead of del, we'll be writing d. So we will write in the same way 1 divided by 4. D, concentration of NH3, that means the first reactant with respect to its time. Stoichiometric coefficient, then D, concentration of the second reactant with respect to time, followed by the product. First product concentration with respect to its time, then followed by the second product, concentration of the second product and with respect to its time. This is how you will be writing your average rate and instantaneous rate. Let us try to solve one problem. The concentration of a reactant A changes from 0.055 m to 0.028 m in 32 minutes. What is the average reaction rate over this period? Express the result using both second and minute as the unit of time. So what we have to do here is we have to express the result in second and time. The concentration of the reactant is given. So the average rate will be expressing only the reactant, not the product. This is just a general reaction. Even if you don't write, it is fine. But we are just showing that the reactant is being converted to the product. Now the average rate will be writing only for the reactant, because only the reactant is mentioned in the question. So the average rate of the reactant is given as by time. We are not writing the coefficient because here you see that the coefficient is not mentioned. Whenever coefficient is not mentioned, it is always 1. So even if we don't write this, also it is indicating that it is 1. Now the concentration is already given, that it changes from 0.055 m to 0.028 m. So whenever we are writing, it is always the final concentration minus initial concentration. We have a minus sign. Our final concentration is 0.028 minus 0.055 divided by time. What is the time given here? It's given 32 minutes. So upon opening the bracket, minus into minus, it will be plus. So minus 0.028 plus 0.055, we will get 0.027 divided by 32. So upon division, we get 0.00084 minute inverse. M is coming from the concentration. That means what is the unit of concentration? Mole liter inverse. Instead of mole liter inverse, we can directly write molarity. And minute inverse comes from, since it is 32 minutes, when it goes to the numerator, it will become inverse. Now we got the result in minute. We have to even get our result in terms of second. So what we will do is, in order to make this second, we can directly do the conversion from here, or we can also make it in power term. In order to make it power term, what we will do is, since we always put the decimal to 1 point ahead of the number, divided by 1, 2, 3, 4. 1, 2, 3, 4. We are getting 4 zeros. And it is in the numerator. So in order to push this decimal point towards fourth step, this 1, 2, 3, 4, when we put in the numerator, it will become 10 to the power minus 4 by pushing the decimal point to fourth place. So it will be 8.4 into 10 to the power minus 4 m minute inverse. So in order to convert this to second, we have to divide it by 60 seconds. Upon dividing it to 60 seconds, we get 0.14 into 10 to the power minus 4 m second inverse. Or you can also write this unit in this way, 0.14 into 10 to the power minus 4 mole liter inverse second inverse. So this is how you are going to calculate if you get such type of problems.